So, a very warm welcome to everyone who could join this evening. I think I will start now with a little introduction of ourselves, of the software engineering community, and then later I will give over to Daniel to present us something about open source. So let's start. We are the software community of Telekom MMS, and we have a small introduction video for the start. So let's begin this. So yeah, that was our small German introduction. So as I said, we are the SECO, the software engineering community. We are in existence since 10 years now. So we're having our anniversary year this year. And our target is, our goals are to connect experts to further knowledge distribution and knowledge sharing in our company and across basically the whole developer and engineering communities, mainly in Dresden, Saxony, and some wider areas. Whoever can visit our meetings and our events is welcome, regardless your origin. So we do a lot of stuff. For example, we organize the Dev Day in Dresden, which is an in-person event, usually in Messe Dresden, where you can meet a lot of interesting people and listen to interesting talks and have a nice evening with good food and good talks. I think our meetup group should be known to you, otherwise you wouldn't be here. So it's good to observe. And we're also organizing some hackathons where we are doing some events based in the sooner time on AI development and AI advances, but also on other things. We originated in T-Systems MMS, which is now Telekom MMS. So I have to say something about our company. The Telekom MMS exists since 28 years. We make more than 200 million euros in revenue per year. We have 2,000 and more digital experts, project leads, agile people, students, nerds, developers, you name it, we have them. And we have quite a few customer projects. We're working agile, and our average age is 37 years. Kind of grew with us. I started in this company then where our average age was almost 30. So I'm contributing by getting older. So please excuse me. We also have a visible women's share in our with our colleagues. So that's also good. And yeah, we're doing a lot of stuff, as already mentioned. We're doing different technologies. We are focusing on whole services as Telekom MMS. We are there for you 24/7 and basically all in Germany and a few places worldwide. For the community aspect, I already said you can visit us at Dev Day and our meetup group. We also have a YouTube channel where you can watch older videos, and also this recording once it's put online. And we have a landing page with information and further details for our future events and notices. Small mention for the next event, ending November, Eberhard Wolf will be here to discuss how to do architecture, but certainly not future-proof, because nobody wants that. might be a bit controversial, but with Eberhard, it should be a very interesting talk. Can put it to your heart to also make time for this slot. Small note, as already said, we're recording our meetups. If you don't want to be seen or heard on YouTube, we would advise you to stay quiet and use the chat. We will tell you when the recording stops and you can talk again. You can also talk if you want to be on YouTube. That's no problem, to give Daniel something to work with. Yes, and then, well, then up to today, Daniel Eder is here and he's talking about open source and giving us an introduction to the whole complex theme. Hello, Daniel, and the stage is yours.
Hi, thank you. Let me start by sharing the screen before introducing myself. We want the PowerPoint slide. Okay, quick tech check. Can you see my slide? Thank you. That says thumbs up. Before I get into the slide set and before I talk about myself, really quick about this little seminar, webinar maybe. I really welcome questions throughout the talk, so please just ask them. I will not be monitoring the chat because I will have the slides in front of me to talk about those. So please, if somebody sees something in the chat, please just like tell me on voice. I will check out the chat and then answer the questions. Okay, we already heard the topic is open source, and I will tell you more about that in a second. Real quick about me, why I'm qualified to talk about open source. First off, that picture is way outdated. As you can see, my hair grew a bit, but that's actually still me. My role at Deutsche Telekom is I'm a senior advisor in the open source program office. That means I'm responsible mainly for open source strategy, also for governance topics and project management if we have big public-facing open source projects. And finally, the topic that we will focus on today, that is open source compliance, meaning all the legal stuff related to open source. And as we will find out throughout this talk, even if developers may have a different perspective on open source, actually, fundamentally, it is very much a topic that has a lot of legal components that you have to be aware of. So today we will have two parts of this talk. We will do an introduction into what is open source, what does it mean, beyond I can download and run random software. And then we will focus on open source compliance. And that is in the sense, if I build a product, if I distribute something to someone, what do I have to do to be on the safe side legally, to have a product that can also flourish in the market? And if you're through that or during that you have any other open source related questions, I will do my best to answer those as well. Starting with what is open source. We have to take a step back when we talk about open source. We have to take a step back and maybe go to the time before software, because, and we will discuss this a bit more in a few slides, open source and open source licenses fundamentally are functions of copyright law. So the first question we should ask and answer is, what is copyright? And luckily, it is a term that is very descriptive. It really means what it says. The copyright is the right to control who creates copies. And that originates in the past, like way in the past, hundreds of years ago. And when we go back, like maybe 500 years, and we were talking about, well, what could you copy back then? What would be interesting in terms of intellectual property? It would be texts, it would be books, maybe songs, but mostly books. And back then, if, say, I write a book, and it turns out to be extremely successful, because it's very interesting, then any of you people could buy that book, obviously, could read it, but you could also try to profit off of it. You could pay some monks to create 100 copies of that book and sell these copies, and you would not have to pay me any royalties. So this is this original state. Before copyright was introduced, it was a free-for-all. If I got any piece of intellectual property, I could basically pretend to be the author, sell it, make money off of it, and the original person could die poor, which by the way, wasn't uncommon. At some point, that changed. And a big driver for that change was that when the printing press arrived, and generally books became more popular, and not just books, also science texts and so on, leaflets, newspapers, there quickly, this free-for-all state quickly became problematic. Because initially, this free-for-all actually encouraged science and all other creative works, because it was very easy, low threshold to get started. You could take an existing work, modify it, resell it, and so on. The problem is, at some point, people realize that if there's a free-for-all, then you don't actually have to be creative on your own. You just have to take someone else's work and sell it. Go to the printing press, create 1,000 copies. So the legal situation changed and copyright was introduced. And starting in the UK, and then it spread over the world. And at this point, suddenly you couldn't just sell anything. You actually had to, if you wanted to sell a book, you had to have the authorization of the author. And the author would usually charge you royalties to sell the book. Now, this legal framework sort of carried over into the modern digital world as we know it. It took a while. It took some adjustments to copyright, and it took some case law in the US and also in the UK. But we arrived at the conclusion that software code is also covered by copyright, and that the author has certain rights that cannot be taken away, and that allow the author to charge royalties for software. And in these early internet communities, that was actually also a free-for-all because the legal situation wasn't clarified yet. This idea that copyright actually applies to software sort of really dampened innovation, because suddenly you had to be very careful. If you use existing code, you couldn't just take a program and hack away and create a new version. You actually had to check, the legal situation, buy it, and maybe IBM had the copyright of that, and that was very uncomfortable. So there was the idea born, okay, now we have copyright, but how do we go back to this original state? How do we enable innovation in a more, free way without impediment of having to pay someone? And at least if an author wants people to be able to use it, how can they enable them? And this is when copyleft was born. So we had this brief period of free-for-all, and as I already mentioned, we had this area that copyright applies to software as well. So we come up with copyleft, and copyleft is actually a copyright mechanic, because copyleft depends on the copyright, which is a bit odd maybe, but really copyright tells us that the author can control who can create copies. And copyleft is such a controlling framework that tells us who is allowed to create copies. And very, very simply put, copyleft just means, and by the way, copyleft could also exist outside of open source. You could also make a copyleft clause in any normal license contract. It just doesn't make a lot of sense in the most commercial scenarios. But copyleft as a copyright mechanic means I'm allowing you to redistribute software as long as you apply the same license under which I gave you the software. And as I already mentioned, what this license that you also have to give to others might be is generally open. But of course, as history shows us, and also the current practice, generally this is only used in the context of open source licenses, because otherwise we are usually not incentivized to allow our licensees to even hand over software. Now, before we go deeper into the open source licenses, let's stay a little bit with copyleft, because in some ways, still today, copyleft is one of the most important functions of open source, especially now in this world of cloud software, where open source has gotten a completely new meaning, and there's now new licenses popping up that are trying to recapture the 1990s feeling of copyleft. So let's just take a quick look at what copyleft actually is, in the sense of where its limits are. As I already mentioned, copyleft means that we can force downstream users to always use the same license and not use another license, but there's limits to that. And in the strongest sense, the so-called strong copyleft that we know from the GPL licenses, starting with GPL 1, 2, and 3, and now also AGPL. Strong copyleft means if I have a piece of software and that is GPL licensed, okay, it stays GPL licensed. That's it. If I get it under GPL, I have to forward it under GPL. But what is if I'm making my own program and I just want to use a library, which is probably the most common scenario of open source usage in any commercial scenario. And okay, now I have a copyleft licensed library. What does that mean for my product? And this is where we have to differentiate between the different types of copyleft. Strong copyleft means if in my final product that I produce, this library ends up in the same process as my own code, then my code is, I don't like this word, but it's very descriptive, infected. It means copyleft applies to my code as well. So if I have a GPL library, let's say, fictional example, it's a logging library. Everybody needs a logging library. And I include this logging library in my program to log something, then my program also will be under the same copyleft license, for example, a GPL2. I can only escape this strong copyleft effect if I keep the library in a separate process. So for example, I could do, on Linux or on Unix systems, I could inter-process communication with named pipes, or I could use a network socket, maybe even a nice JSON-based API. So if I have some sort of process separation, then the copyleft of that library will not affect my own program. However, and this is so this is how it started with copyleft, but very quickly it became apparent that that is sort of uncomfortable because many people, especially in a commercial setting, sort of shy away from using software under strong copyleft because obviously it affects their own commercial software and restricts effectively how they may make money off of the software. And this brought into the game weak copyleft. And the most common example is the LGPL. And the LGPL or all other copyleft, weak copyleft licenses have the effect that the copyleft doesn't have the process barrier, but it's even narrower. It's only for the same library. That means if we again take the example of our logging library, if I want to include it in my awesome program to create logs, I can now use this library and only the libraries under the LGPL. My own program, for my own program, I can choose a license as I like. That could be another open source license, or it could be a proprietary license, but I'm not forced to have the same license. So you might ask, okay, then why copyleft at all? Well, if I want to improve this logging library, if I realize, okay, we could do some really cool stuff with logging, I mean, super uncreative. I have no idea what you might do to improve logging, but maybe, I don't know, add colors. Then you could go, because it's open source, it's under LGPL, you will find the source code probably on GitHub or GitLab, and you could modify that library and release it on your own. And this is where weak copyleft comes into it. This modified version of the library, you cannot release under a license of your choice. You cannot make a commercial product out of it, at least not under a proprietary license. You are forced to, again, release it under the same license, the LGPL. So weak copyleft is really intended not to spread to all downstream users. Instead, it just intends to keep the main, the same library always open source. So it still has this effect of protecting innovation, keeping innovation open, but is a bit more permissive. It allows also people to do their own thing in their own software. And then there is a new type of library, the new type of license, the AGPL, which is basically even stronger than copyleft. And it's a bit more complex than that. I can't go into it too much today unless we want to discuss it later. But quite specifically, it means the effect of copyleft, the effect of having to use the same license also applies if you have a network interaction. So this was, as one could guess from this network interaction, was intended to cover cloud products, software as a service products more. And why we even need to cover software as a service, we will go into later. But even from this slide, you can recognize it. In software as a service scenarios, you often don't have this whole process stuff. Maybe you have an HGPL licensed software that is in a different process than your main stack that you program on. But with the HGPL, you might still have here licensing situation, and we will talk about this in a little bit. The effects of copyleft we pretty much already covered. We have this limit to the license choice, and commonly included with this license choice question, meaning if I receive GPL software, I have to forward it as GPL software. I have to check what the license says, but as far as I know, all copyleft licenses actually include the requirement to redistribute source code. And the exact mode of that we can also discuss later. But obviously, I think everybody knows this. This makes especially corporations a bit careful with when they use copyleft. However, I will also mention this later again, at least in Deutsche Telekom, we do not see that as a problem. I've never had a project that had to change their source stack, use different open source software just because of copyleft. So in almost all cases, you can fit the business use case to still work with copyleft. We talked a lot about copyleft. Now we should talk about open source licenses, because as I mentioned, copyleft can be part of open source licenses, but doesn't have to be. So what is an open source license? In the strictest sense of the word, if we want to call something an open source license, we have to read the open source definition by the open source initiative. And if a license fulfills all the requirements, it's about 10 paragraphs, then it is an open source license. Effectively, that is not very useful because in order for it to really be recognized as an open source license by the open source initiative, you have to hand it into them, they review it, and then you get this nice green circle that you can show off next to your license and to products licensed on this license, and it means it is recognized as open source by the OSI. Practically, there is a lot more licenses than the people at OSI can reasonably review in their lifetime. So there's also a more general definition, and that is an open source license is a license that allows you to freely use, modify, and share software or other data. Commonly it's software, but of course nowadays with open data licenses, it's a bit more diverse. There might be a fourth freedom that some people mention, and that is the freedom to reverse engineer. I usually just name these three because it's sort of implied if you're allowed to modify it, then the way you modify it shouldn't be restricted. And obviously, usually you have access to the source code. But a very important part is that you have these freedoms and that you don't have unnecessary restrictions on it. So this is also a very important part that we will also come to in a bit again. And that is you're absolutely allowed to use open source in a commercial setting. If a license says you can freely share this, but you're not allowed to make money with it, then it's actually not an open source license because it does not allow you these freedoms. It restricts them. This is something that is actually a relatively modern phenomenon that now comes up again in the software as a service and cloud space, but that's not an open source license. A better word would be a source available license, but we'll have a slide on that. However, what is allowed to still be an open source license is to give certain requirements. So you cannot just wholesale forbid certain use cases, but you're allowed to put certain requirements. What does that mean? This is open source compliance. We will talk about it in depth a bit later, but specifically it means use of an open source software is always generally without requirements. If I download a piece of open source software and I just use it privately, there's no restrictions, there's nothing I have to do. I don't have to worry about copyleft. I can use Linux and program something on there that I will sell. That's just use, that's no problem. However, distribution is when the requirements of open source licenses come into play. Distribution, we'll talk about that in a second. The one scenario we have to keep in mind is the HGPL. We will also come to this in a second later on this slide. But whenever I distribute software in any shape or form, as I put it here, that could be a download, that could be a floppy disk that I hand to someone, or a USB drive. If I distribute, then I have to look at open source compliance. And from a product perspective, this is extremely important, because that means as long as I develop my product, everything is happy and fine. But as soon as this product sort of gets in touch with customers or with any third parties, I have to look at the open source compliance. So what is distribution? I already mentioned this could be a download. This could be some other way to send the software to someone. Distribution can be a bit hard to define, but a good way to be sure when you always have a distribution, if someone is able to copy the binaries, or technically also the source code. But as soon as you can copy the software, you definitely have a distribution. That can be interesting in cloud scenarios. For example, if I host software as a service, in many scenarios, I actually don't have a distribution. So I could use a GPL, let's say, mail server. And as long as that mail server is just running on my server and I'm just offering, people can use their mail clients to connect to it, then I actually don't have to do anything. I don't have to comply with any of the requirements of the license. However, if, let's say, I'm offering mail servers as a managed service, and somebody, the customers bring their own cloud, they have their AWS account that they want me to install the mail server in there. Now they are able to copy the binaries because they can access their AWS instance. Then we have a distribution, and then we have to talk about open source compliance. And then, the special case HGPL, I mentioned it before with the process barrier. The HGPL, if we have an HGPL licensed mail server, then actually we also have to take care of open source compliance in that case, because HGPL gets activated not just by distribution, but also by network interaction. Other than that, it works the same way, the compliance, the things I have to do are the same, but it means if I have a mail server, and if it's, to give an example, if it's GPL licensed and I make an awesome improvement to the mail server, improve the speed by 200%, if it's GPL licensed, I do not have to share the code with anyone in a software as a service scenario. If it's HGPL licensed and I make the same improvement, then I'm actually forced to give back this change to make it available to others. Now, a quick overview. We already talked about copyleft. We talked about what open source licenses are in general, what types of open source licenses exist. We have the first class, and they are not actually open source licenses, but they have a similar effect. They're public domain and public domain-like licenses. That basically means I put the license text, and the license text is do whatever you like. No requirements. I give the source code, world can do with it whatever it wants. We have permissive licenses. These are the first real type of open source license. A good example is the MIT license or some of the BSD licenses. And what permissive means is I have very few requirements when I distribute. We always, when you talk about open source compliance, as I mentioned on the slide before, we have to talk about distribution. And when it comes to permissive licenses, there's very little I have to do. Usually all I have to do is I have to mention, okay, I use this software. I have to name the software, I have to name the license, and I have to name the copyright holders. That might not be as easy as it sounds now, as we will discover, but fundamentally, I don't have to share source code, which is what most people worry about. Then I have weak or strong copyleft licenses. We already discussed those. And then there is some other types of licenses, and please be careful with those because they're not open source licenses. If something is declared as freeware, that has no meaning at all. That fundamentally only means that you can download it for free. Nothing else is included in that word. That means you may not be allowed to share it. You may not even be allowed to run it for more than a few months. So that is a very careful, also nowadays it's a rare. Very rarely something is advertised as freeware, but just in a commercial setting, you should be careful whenever this comes up. And then there's this new group of source available licenses. I already alluded to them a few times. This is a very popular approach currently that companies did. And why source available? Why not open source? What's the difference? Source available licenses also allow you to see the source code, but they do not give you these three freedoms. They restrict them. And usually that means that commercial use is restricted. And I think we have to thank Amazon for the existence of these licenses, because what Amazon did is they very intensively used open source software and only offered it as software as a service, which meant, especially with copyleft licensed software, that they were able to improve the software, to make innovations on it, but never share them again. So they ingested copyleft software, but never had to give back, by basically having this loophole that copyleft requires distribution to be active. And so the first reaction to this was the HEPL license. And as a consequence, Amazon and other cloud providers became a bit more convoluted and tried to hide the network interaction, pushed this HEPL licensed software very far back into the stack to sort of legally have a shield against this copyleft effect via the HEPL. Now we have source available licensing that basically just state, if you use this, if you offer it as a service, as a hosted service, then you have to pay us. So that's just to be aware of, especially with cloud products. There's this trend that they're not actually open source anymore. And if you have commercial offerings, you might have to pay. The newest development from just a few weeks ago is from HashiCorp with Terraform and everything in the Terraform surroundings that are now, I'm not sure if they already relicensed. I think they will relicense by end of year to a non-open source license. So I didn't include the example here, but all the examples are the Elastic license version 2 and the SSPL in MongoDB. I already mentioned that before. What types of open source software can be used? The Telekom standpoint is you can use all types of open source software. The OSPO does not make any restrictions. However, the one restriction we do make is if you use open source software, you have to use it compliant. And just in 2 slides, we will talk about compliance specifically. Before we go to compliance, a quick overview. Open source software versus free software, because you often hear the phrase free and open source software or free libre open source software. So we have to ask the question, what does free actually mean in the context of open source software? And I'm glad that I'm doing this talk in English now, because in English, it's nice because free has so many different meanings, which is sometimes a bit harder to explain in German. So the first question is open source software. Is it free as in free beer? Second question is free as in freedom. And the third one is free as in puppy. What does that mean? Let's start with the beer. Free as in beer. This means, does open source software have to be monetarily free? Do I get it gratis or do I have to pay for it? And this is yellow because unintuitively, it's actually possible that you have to pay for open source software. And I would bet that every single person that is listening to me now, and also all the YouTube listeners, definitely already paid for open source software. You don't pay for Linux per se in most cases, but you might pay for Red Hat Linux. And you probably paid for your Android phone that is packed full of open source software. What I want to say is open source licenses actually do not keep you from charging money for software. If you receive something as open source, you can resell it. However, you still have to comply with the license terms. And in most cases, that means that the recipient, or in all cases, if it's real open source software, means that the recipient can give it away for free. So that restricts your business model. And that's why in many cases, open source software is also free without having to pay for it, but that is not a built-in requirement. The second one, free as in freedom, that gets the green border. Yes, this is what we talked about before, the 3 freedoms. Free and open source software fundamentally refers to freedom in the sense of liberty, not in the sense of monetary freedom. And finally, free as in puppy. Again, this is very important from a commercial perspective. When I ingest open source software, when I use it in my products, I have to look at the life cycle. Even if I don't have to pay to use an open source component, I don't generally pay to use some Node.js packages or some Maven packages. However, I have to consider the total cost of ownership. This is the puppy example. If somebody gifts you a puppy, you do not pay for the puppy because it was a gift, but for the next 10 years or so, or if you're lucky, 15 years, you spend a lot of money on the puppy, keeping it healthy, feeding it, paying a few €1,000 for the vet appointments. And the same applies to open source software. You cannot just use open source in a project. You also have to budget for it to make sure if there is a security issue. We had 2 years ago Log4j. So if you have something like that, you have to be prepared to have people available to address it. So that's why the most correct way to abbreviate open source is actually FLOSS, free, libre, and open source software, which libre, liberty, Italian implies it's not just about monetary freedom. We now reach the open source compliance section. Before I go into that, do we have any questions so far? I guess not in the chat. Okay, then I will just move on. We already laid the foundations for open source compliance. Now we have to look at what do we actually need to do. So just as a reminder, in most cases, we have to think about open source compliance when we distribute the product. In some cases, also when we have a cloud scenario. If there are specific questions about cloud scenarios, we can also address them. But generally, this rule that I mentioned before is very important. If you have HEPL, you have to think about open source compliance. If you have a non-open source license, like for example, what they call business source license, I think, from HashiCorp, the Elastic license, the SSPL, or the so-called commons clause, then you're outside of open source compliance. If you have any of these three, then you're actually in the commercial sector and you have to pay money, but you still have to take care of them. And finally, also in cloud, if you have a sort of managed service scenario where the customer brings their own cloud or has an on-premise solution and you install the software on their servers, then also you have distribution, you have to think about open source compliance. The fundamental principle of open source compliance is paying by doing. So we just mentioned that generally we don't pay to obtain open source software. We may pay, but generally we don't. But we still have to do something. In one of the first slides, we had this certain requirements phrase, and this is what we're getting to now. This freedom to use, modify, and share is only granted to us if we fulfill the requirements. It is exactly the same as if it was a contract that we paid for. Imagine you're buying Microsoft Office, a license, and you get the software and then you don't pay. This is usually hard to do because you're required to pay upfront, but imagine you're charging back your credit card payment after you pay. What Microsoft will do is they will just turn off your subscription or revoke your license. So in order to receive the use of the software, you have to pay for it. And if you don't pay, you don't get to use it. And open source works the same way, except you do not pay with money. Instead, you pay with information. I already mentioned this when we talked about the types of open source licenses. In most cases, that means licensing information. That means if I distribute a piece of software, I have to include, for example, a PDF file. And this PDF file lists all the open source components of my software. So for example, if let's say I work in the Java world, I create a program based on Java Spring framework, then I will have a huge list of all the Spring components in there and probably some additional Java libraries. And for all of these licenses, I will, for all of these libraries and components, I will include their license information. So that will be mostly Apache licenses, maybe a few MIT licenses, but I will have to list it. For each component, I tell them what was licensed. And then I also have to include the license text itself and the copyright statements. And then in some cases, when we're talking about copyleft, I might also have to include the source code, or at least this is called a written offer. I don't actually have to include the source code all the time. That could be very cumbersome. I can also just include a little offer and say, okay, you're entitled to receive the source code. If you want it, please send me an email. And if I receive that email from someone, then I send them the source code. That's also a possibility. But fundamentally, I have to share the source code if I have a copyleft license. And then there might be certain requirements based on the license in addition to these three common ones. An example is the Apache license has a clause that basically just says, if you have a file with the file name notice in the source code, then you also have to distribute this notice file to all the recipients. And generally in the notice file, you again just have copyright statements, but the license tells you to do it, so you have to do it. Now, we haven't uncovered the challenges behind that yet, but even at this point, it's a fair question to ask, why should I do that? Because it sounds like it might be a lot of work. First is, it's a question of fair play. You pay for your Microsoft Office subscription, at least I hope you do. And you also pay for your beer and your coffee. So you play by the rules. Copyright is law, it's not optional, and you follow all the other laws. And so you also follow this law. On top of fair play, there's also a question of recognition. Open source is not just a legal framework, and it's not just software, it's also communities. And fair players get a good reputation. An example is, for example, Microsoft. For a long time, Microsoft did not have a good reputation in the open source ecosystem, but they massively improved it because they started to really embrace open source. And obviously, there are still, I don't want to get into this discussion too much, there are still many questionable moves that Microsoft makes because they're still a corporation and they're still bound by capitalism and they want to make money for their shareholders. But they started to play much better with the open source communities. So there's recognition, and this also really helped them as a business. And finally, if fair play and the carrot is not enough, there is still the law. And I already mentioned, if you don't pay for Microsoft Office, then Microsoft might revoke your right to use Word and so on. And the same can happen to you if you do not play by the open source license rules. If I use a piece of open source software and I distribute it as part of my product, and I do not include open source compliance documentation, or I do not include the source code, or do not include this offer to get the source code, then the copyright owners can sue me, and they can get damages payments. Schadenersatz, German term. And on top of that, I might, because I'm violating copyright law, you might also be in the criminal law. If I do this intentionally, knowingly, then I will also get criminal fines or worst case jail time. And then on top of that, if I do not fulfill the requirements of the license, then the license no longer applies to me. That means these 3 freedoms that I got before to use, modify, and share are revoked. And if you put this in a scenario of a product you distribute, that is actually very severe because it leads to a product recall. So I'm from Deutsche Telekom, so we might be distributing a router. And if we decide not to do open source compliance on a router, then any of the open source authors of the software on that router, that means the thousands of people that wrote Linux and so on, each and every one of them can demand that this router is recalled. And it will also be successful. So they will have a very good negotiation position to get us to pay them money to not do that. But fundamentally, they have the right to enforce a product recall. And a product recall with a physical product literally means the product will be sent back, which also in turn means that Deutsche Telekom, whoever suffers this recall, will have to pay, again, damages to their customers for them no longer being able to access the internet. And a product recall can also happen to cloud software where you just have to turn it off and again, compensate your customers for their loss of business. So the consequences can be severe. So even if you don't like the fair play and the carrot, in the end, the law forces you to do it. When do I have to do open source compliance? We already largely discussed that. What you have to keep in mind is it's a use case specific question. So I cannot say, for example, I don't know, MySQL. I cannot say MySQL, if whenever I use MySQL, I have to do open source compliance, or I don't have to do open source compliance, or I have to always distribute source code, or I don't have to distribute source code. I have to look at the use case. Because it will be very different if I host it as a service, or if I use it internally for one of my products as a backend, or if I distribute it to a customer. So the use case determines the requirements for open source compliance. This is just a repetition of the slide we had before. It's all about distribution. Now, open source compliance, we had this slide where it said, okay, you have to include all the components and the license text and the copyrights. And okay, so that can be challenging, right? So let's look at that. First challenge is, I mentioned license-specific requirements. So there's certain things that all licenses have in common, but in the end, licenses were written by humans. And the only rule that we learned about is they have to give us these 3 freedoms. The requirements are pretty open. So we have to know about a lot of licenses to fulfill them. Now we have just OSI approved licenses, are over 100. And then we have over 200 licenses that White Source found that also comply with the general framework of rules, that this general definition of open source that I mentioned. And on top of that, we have a lot more licenses that are not open source, that are just source available or just some additional stuff that you also have to take care of. That's not open source compliance, but that's still license compliance in the proprietary sense. So challenge number one is, if I have a product and I have some open source in it, I might have a lot of these 200 possible licenses in there, and I actually need to know about what these licenses say so I'm able to fulfill them. But in my opinion, the bigger challenge is this one: transitive dependencies. So in this example, let's say we have a project and we use the Java Spring framework and we use the now famous/infamous log4j library. Then we have two dependencies that are open source. But that's not true, because the Spring framework alone is like, I don't know, a few dozen libraries. So that's already a handful of those. And each of these libraries in the Spring framework, and also log4j, in turn use some other Java libraries to enable their functionality. And each of those also uses libraries. So it's sort of libraries all the way down instead of turtles in this case. And that can get pretty big. So even relatively small projects can end up with a few hundred or even a few thousand components, open source components that are in there. And when you click compile, depending on the specific programming framework and technology you work with, but generally when you click compile, you will get a package that you can distribute. And this package that you can distribute, in most cases, contains everything. So hundreds of libraries all packed in there. And that means that all of these hundreds of libraries are being distributed by you. And you have to do open source compliance for all of those. And that is no fun. So the consequence is we just have a large amount of dependencies. That is our challenge too. Part of that challenge is, in order to do open source compliance, I need to know the licenses. That means I need to scan the source code, because each library might have more than one license. Small example, Linux kernel, I think it was scanned a few times, but I think current count is around 400 licenses just in the Linux kernel. And other open source projects are not quite as bad. But generally, if a library says I don't know, Apache 2, you just cannot believe it, because in the source code, there might be other licenses, because people wildly contribute to open source. So you have to scan a lot of source code to find all the licenses. And then you have the problem that you will have false positives and false negatives, and somebody has to check hundreds or thousands of results. And then you have the big bad guy Docker container. From a development perspective, Docker containers are awesome. You can just transport a piece of software and it will work in most platforms easily. But the problem is they are stuffed full with open source software. It's sometimes very hard to find out what's even in the Docker container because of the layer structure. And also Docker containers are full of binaries, so you can't just scan the source code. Sometimes it's even hard to find even what version exactly of which software is in there. So very intransparent, almost impossible to compliantly distribute. So all of you that probably already have products distributed with Docker containers, you can now start waving red flags, because that actually is a problem and it's very hard to solve. How do you solve it? In order to do open source compliance, you need a software inventory. We'll get how to do that in a second. So you have to be aware of all the software that is in your product. And as I mentioned before, with Docker, this is quite hard. With other technologies, with Gradle, with Maven, with NPM, whatever your framework is, with Python, it's usually reasonably easy because you have a package manager and you can query this information. If you go back in time with C++ projects, it can be much harder. Once you have the software inventory, you have to do license scanning. Ideally, that's one software does all of that for you. And finally, you have to generate the compliance artifacts. This is just all the information we mentioned before, like a huge PDF file full of all the components, all the licenses, and everything you found. How do you do it? Specifically, you need software. There's actually quite a big selection of software you can use. At automatecompliance.org, they have an up-to-date list where they just add new stuff as it comes available. And there's a few ones. Forsology is a long-time software from Siemens, open source. That's pretty good at scanning source codes. OSS Review Toolkit is what I personally recommend. It's a bit more modern than Forsology. It's also much younger than Forsology, and it's a sort of all-in-one framework. It does all of it. It creates a software inventory for you. It looks based on package manager metadata. It downloads source code, scans it, and gives you all the information you need. And also it can generate the compliance artifacts for you. So it's sort of a tool chain all in one. Telekom is working on an add-on for it just to improve the quality, but even OSS Review Toolkit as a standalone is very, very neat. And if you have to work with Docker containers, then you should look into Turn and scancode.io, because these are two solutions that at least attempt to get all the information out of Docker containers and create reasonable compliance artifacts. And that's it, actually. This brings me to the end of my talk. And if there's any remaining questions, we can now address those.
Nice, thank you. Especially about the tools, it's always pretty actionable. So
yes, that's what people love.